Okay, so portable painless project setup with Docker Compose. So why is the setup of a project even important? Like, as developers, do we have a responsibility to people that will be using it? Do we have a responsibility to ourselves? Do we need to make projects easy to clone, set up, and so people can contribute to them, fix bugs, provide features? As developers, I'm sure we've all approached a project that is absolutely impenetrable to set up, requires lots of Stack Overflowing, lots of Google searches, lots of scratching of the head to figure out what the hell just went wrong. So a few niggles that I've had personally is, no, I don't want to install Homebrew. I don't like the technology. It doesn't work for me. Some other people obviously use it, but a lot of READMEs I come across say, get started by simply typing brew install this language to install this database. Another one, and a big one, I think, is the assumption that everyone speaks English. So if you have 12 steps to set up your project that involve various paragraphs of writing, someone that may be a brilliant developer and has a bug fix for your project may not be able to contribute to it because they simply don't understand how to get started with your project. So obviously when you're programming, it's obviously in English, but that's programming and being able to understand written English is separate things. It's also important to note that a lot of the traditional setups where they have step-by-step guides on how to get set up, they have a lot of assumptions with them. So some may assume that you're on OS X, that you have this service installed, that you have that service installed, that library dependency is installed. libxml2dev is a brilliant one. I never ever have that installed and it always hiccups. So again, I already have MySQL, Memcache, Redis, Kafka, Cassandra, Postgres, Spark, Hadoop, and Accumulo installed. Why the hell should I install Mongo 2? It gets completely bloated and your MacBook takes 20 minutes to start up because it's trying to start all these services. You may not even need them. You may be working on projects that don't have anything to do with any of these services. Again, oh dear, your project won't build on my machine. I better open an issue. I can't tell you how many open source repos that I've looked at that have 3 or 4 separate issues on people struggling to install and get started with the project. The issues for me of a project are about bug fixes, submitting bugs, submitting enhancements, submitting feature requests. And this sort of helps maintain the nature of the repo. It helps make it slimmer, more concise, and a lot more understandable. Lots of issues regarding how to set up your project. They get tedious and repetitive. I'd love to contribute, but again, I don't have 6 hours to follow 100 instructions. Clearly plagiarized from Nick's more brief of the talk, but again, it's very, very valid. The more instructions you provide for your setting up of your repository, the less likely someone that has nothing to do with it but may have a bug fix for you is likely to provide. Let's go through a painful setup. So I'm sure we've all come across a README like this. Now, this is actually for the MySQL 2 gem. So if you're using the gem, no gem is perfect. They're all written by humans, and those humans are developers. We make mistakes. We write bad code, whatever. So this, again, bundle install assumes that you have Ruby. You have a recent version of Ruby. You have bundler installed as well. Rake, again, that assumes that your Ruby environment is set up correctly, and it's not going to explode. This one also goes a step further and assumes that you have MySQL 2 installed, running, and you have a fair degree of understanding of how to query in SQL, which, given some Rails developers, they might not. So again, it goes on to specify a YAML file where you can configure how the tests are run. So even once you've got through all those steps, you may find out that you can't actually configure it properly. It won't run. So this was what me and Nick were talking about at the start. This was a part of a GIF of a TTY studio of showing the pain of trying to install. Once you run that command, on my machine anyway, it says that my Ruby is out of date and I need to go and update my Ruby. So if I'm not living in the Docker world, I go and update my Ruby. So I go and download Ruby from source. Yeah, I know you can use RVM as well, but to prove my point. So it's going to download it. That part deals with downloading it and then compiling it. And then you go and grab a coffee or a beer or go browse the internet for 5 to 10 minutes whilst it installs Ruby. Again, then once you've got Ruby installed, you go to bundle install, thinking all will be absolutely fine and dandy. And then this GIF goes on to say that your Ruby environment's not set up correctly. So what do you do from there? So you go Stack Overflowing. So I'm sure we've all come across this as well. Another assumption that Ruby likes to make is that Git is also installed on, you might be using Subversion, Mercurial. And then this one's also very fun. You go to install RVM and you get a brew error. So then again, lots and lots of Googling and lots of Stack Overflowing to figure out just what the hell is going wrong before you can even start to contribute to this project in this gem. And that one is obviously my favorite one. I have absolutely no idea what's going on there, what the missing dependency is. At this point, I usually just start pasting random lines of code into Google and seeing if anyone's opened other issues up with them. So I don't know about you, but does anyone else feel like giving up contributing? Yep, exactly. So what do we want as developers? If we were to visit a GitHub repository and we have an idea of a feature or an enhancement, again, a bug fix, I keep repeating those three because it's very important. What do we want? We want portable development environments. Those emojis are meant to be our reactions, by the way. So lots of smiles in the room. Portable development environments. We want to be able to move from OS X to Linux to Windows if you're that edgy. You know, we want to be able to transition between these environments very easily, very fluidly. And again, we need to not make assumptions when we're building repos, as well as consuming them ourselves, that the developer will be on OS X, or they'll be on Linux, or they might even be on Windows. I've seen lots of lovely repositories with C:\/ setups. So we need quick, easy, and instructionless setup as well. How lovely would it be to contribute to a repo that had one setup, one command that you could run, and the whole project set up, and the tests run out of the box? We want to eliminate it works on my machine scenarios. When you have a lot of setup, and a lot of projects here as well, it works on my machine, brilliant. You know, it doesn't mean it's going to work on anyone else's machine on the entire floor, because they might have to do some extraneous steps that you did a month ago. We want to develop in a production-like environment. We don't want separation. We want to be able to ensure that that code we develop is going to run in production. We don't want to spend ages diagnosing setup and configuration problems in production when it works in development. So what is a painless setup? My personal definition of a painless setup is a one-command process, which will then run the commands which will then run all the specs and unit tests out of the box. So introducing Docker Compose. I'm sure you've all heard of it. Docker, Docker, Docker. You can't go anywhere avoiding that name. Docker Compose is built on Docker. It is easy to understand. It's just one file. It allows you to find lots of dependencies, how they interact with each other, as well as network layers. It's fantastically well documented. I don't know if any of you have browsed the reference files on the Docker manual, but it is really well documented and includes lots of edge case scenarios, examples of them. It's simple to set up projects of varying size. If you've got a tiny library or a gigantic monolithic application, it handles them. It's one single compose file. If you have lots of services, it may extend over hundreds of lines, but it will eventually just be one single compose file. Docker Compose also allows you to develop in the cloud. So my only experience with this is through using Amazon's ECS, but you can actually develop Docker Compose in the cloud. So any project's dependencies, like for example, a development database, can be loaded up and connected to the cloud. It's also compatible with Docker Swarm as well, which is Docker's own deployment of orchestration technology. Dependencies. You can get lots of public images for all the databases. Either you can run your development environment against the official ones, or you can run against the Tutum ones. I personally prefer the Tutum ones because they have a degree of extra flexibility. They know that you're going to be developing with these images, and they allow you to have things like boot up scripts, which I'll come to in a moment. You can also get mocked cloud services, because if you're developing on AWS, you're unlikely at some stage going to interact with AWS services. So it's nice to have them mocked in simple Docker images. And as well, one of the things that I'll touch on at the end of the project is cross-project links, which is also very important for when you start getting lots of different microservices that may or may not need to interact with each other at different levels, and how those dependencies interoperate as they go down. So introducing the Docker Compose file. This is a very simple project that has a MySQL database attached to it. And you can see that the services are defined with MySQL. The image is obviously the official Docker Hub MySQL one. It exposes port 8000. I think that's wrong. Sorry, that's meant to be 3306. Never mind. And it defines some environment variables. Now, the environment variables in Docker Compose are quite interesting because if you leave the value empty and you just define the key, it will pass the value through from the host machine, which is quite beneficial if you need to, for example, deploy a project using serverless, and you can use your AWS configure credentials on your host machine and pass them through to the Docker container. Also, the source, you can configure which Docker file it's being booted up from. You can configure the arguments provided to the Docker file. You can say which command it has. And obviously, as Docker Compose allows you to do, it will mount your development working directory directly into the container. So what this means is that if you change a file on a controller or a model or any single file, a script, it will immediately reflect that change within the container when you go to run it. And at the very bottom of the Docker Compose file, it's linking the source repo, so the project itself, to the actual MySQL database. It's very handy. I think that's very concise syntax. It's a very understandable DSL, and it makes sense to me. It's very human readable. So whilst this one was one that had MySQL, as well as a project that interacted with MySQL, let's take a look at a very simple project. So we've just finished a node library that handles Lambda events. So this is a Docker file for the node library. There is no MySQL. There is no command. It just defines an entry point, which allows us to very easily integrate with CI and CD processes as well. Again, the volume is mounted. This was a GIF showing you how easy it is to Docker Compose build. It's just one command, and it will build everything it needs to run whatever is inside that container or whatever commands you have configured. This was another GIF demonstrating how easy it is just to run those tests. Slightly awkward, but never mind. You just type one command and it will run through all the tests without even hesitating. It will just build them up because it has everything it needs within the container configured already, and it will just run them. And it's also key to mention that, for example, in a node library that is on NPM, there is no need to have anything on the host machine, including the node modules folder. So you don't have to have node installed anywhere on your host machine. So let's take a look at large complex projects. So this can either be a monolithic application that requires lots of services like Memcached or MySQL, or it could be lots of smaller isolated microservices that may need to talk to each other. So Docker Compose allows you to link projects. So this is slightly older version 2 syntax with the external links key. And what this allows you to do is other projects that Docker Compose is operating on your machine, you can link them to that API. So for example, there's an event project there that's accessed through a host of events inside the API host container. And as well, there's a shared database. So whether that's a good pattern or a bad pattern, part of the example, but never mind. So this API is able to access a shared database that may be being accessed by other site services as well. In the more modern version of Docker Compose, and what they're trying to push everyone towards, is the use of networks and a networking layer, as this integrates more directly into Docker Swarm. So when you build up a service, for example, here we have an exchange rate service that simply provides an API and runs Puma. It will build up a default external network and join it. So it expects that the main network is already existing and that it will be the default shared network for all the different isolated microservices. So when you boot up exchange rates or anything requires the exchange rate service, it will interact with this Docker Compose file on the network and then boot up said service. So it's all accessed over HTTP using host manipulation. So one of the common things that you may need to do inside Docker Compose is persist your data. If you're in a development environment which has a very large database, or if you need Elasticsearch with a very large index, you may need to persist it across development runs. So one of the ideas and one of the more emerging patterns that people talk about is the use of workspaces. So a workspace is a slight caveat, as it does exist on your host machine, but Docker Compose, I believe, is moving towards supporting it more openly. But workspaces allow you to have it mounted inside your home directory, inside a hidden .compose folder, where the project is isolated inside subfolders, where each particular service can list out a folder and carve its own workspace on your host machine. For example, the database service here has a mounted shared workspace with UsersDB, which allows the MySQL database to be persisted across runs. So here, this is actually a good example of the Tutum MySQL image, which allows you to have an onCreateDB hook, which will create the user's database if it doesn't already exist. So shared workspaces, they're very handy, and they're a nice pattern to have for data persistence, because they don't allow you to sort of put your working directory, they allow you to put data outside of your working directory whilst not fiddling with anything or not having to include extra files in git ignore. So one of the things I like to say is avoid data containers. So if you have a large monolithic application with a large database and you want to build the database, import the data, and then store that image, I would say it's a slight anti-pattern, as images and containers are meant to be stateless. So I would try to avoid data containers, as they will get quite large. They're very difficult to migrate data, take data off, build data on. And obviously, once you stop running that container, if you run it again, it will revert back to its original previous state. The benefits of Docker are quite easy to see. It enables and encourages a one-step setup, which I would have demonstrated if the GIFs are working. It makes no assumptions about what environment the developer's on. They could be on Windows, it could be on OS X, it could be on Linux. Because everything is run inside the container, and the Docker Compose interface is the only part that lives on the host, it allows you to build environments where it's self-contained. You can install libraries with knowing that they will work. It drives open source contributions as well. Going back to the example that we had previously with trying to contribute to the MySQL 2 gem, if that gem was inside Docker Compose, and I did try with, unfortunately, failed before. If it was inside Docker Compose, it would have been easy to build the project, make the alteration, and then run the spec tests. But without that, you just get into a Stack Overflowing mess. It has lots of CI and CD benefits as well. Services like Travis, Circle CI, Drone, Jenkins, and they all support Docker builds. So you can supply a base image, or you can supply the image from inside the project itself, and then build and run the tests with custom commands. So the only caveat, which I should have touched on a little bit before, is that it does assume that Docker is on the host machine as well, which does, whilst removing lots of dependencies from the host machine, it does require one project dependency, being Docker, which I think it's maintainable because it's one dependency, and it's pretty safe to say that Docker is installed on most computers now, but never mind. Possibility to develop inside production containers as well. If you have a container that you run in production, which all images are built against, it definitely helps to develop inside those containers because you know exactly what to expect inside that container. And that's it. Any questions and hopefully answers?
The GIFs will be available. They can be viewed on GitHub.
Okay, yes. I think you showed me how to do it before as well, didn't you? Does it run like that? No, never mind. Never mind. Okay. Any other? Do you see?
Yeah, you asked about what are the other storage requirements,
So what are the performance requirements of running Docker? So on OS X, it runs it via the Moby VM. So it's before Docker for Mac existed. It used to be boot to Docker, and once they started officially supporting Docker for Mac, they used Moby VM instead. Any volumes that are mounted from the host machine into the container itself, they're provided with the Fuse driver at the moment, which does have performance concerns, so to speak, especially for large projects, because it can be quite slow to execute tests, as the files need to obviously be brought over. There is an open issue on that, I believe, on the website, on the GitHub repo, sorry, and that does talk about moving to other styles and other file systems. Anyone else?
How do you backtrack? How do you try and get all of your brew install repos, which there's hundreds of, into this one standard? Because surely, in my head, the older stuff is almost more important because the install and setup might be more out of date and more complex.
Yeah.
So it'd be nice to have it.
So how to migrate traditional setups into a one-step setup. I would start with a simple Docker file and then build it up from there. Learn what commands are needed to get from a point where you're at the very start to a point where you can execute the tests, and then build them up very step by step. If you know exactly what libraries are required by a project, you can actually just dump them all in the Docker file, and then it will allow you to very programmatically build up the project. Convincing people to move from a traditional setup, I think it's terms of opinion on whether they want to adopt Docker or not. That's also quite a big one. But also, I think if you sat someone down in front of their own traditional setup on a fresh laptop and then said, get your own project running, I think that might be convincing enough, depending on what environment that is as well. Yeah, so if it was a traditional setup and you had a very brew README and you sat that developer in front of a Windows machine and said, have fun, get your tests running, that might be quite difficult. Yeah. Any other questions? How does Docker Compose orchestrate the startup of services? So the orchestration of services is sort of upwards. If you're trying to run, say, an API that requires two other APIs, you can either define them using the external links, which then Docker Compose will then boot that dependency up as required. So it will define that the top API as a the two underlying APIs as a dependency of that service. So it'll just start it in the same way it would start a database before the application starts. But that is handled with Docker Compose as part of the external links. It always makes sure that it boots up those external links before your project is started. In terms of race conditions, that's a different argument, because obviously some services may take 20 seconds to boot up and some services may take 5 seconds. So that's a challenge that I have to sort of find a solution to on a case-by-case basis. You can build up a dependency tree essentially of different services. So if I had project A that required project B and project B required C and D, if I required project A using an external link, it would boot up project B with project C and D as well.
Got a question from Slack. Hamza asks, what is the best way to deal with private gens that are needed inside the container? So things that need your SSH key.
That's a very good question. Typically, if you require GitHub credentials to fetch that retained container, they can be mounted into the container itself. So that's one way to get around private requirements. If you mounted your SSH directory into the development container itself, you would be able to access GitHub. That's also assuming that Git is installed on the container as well. inside the vendor folder. Well, if they're mounted inside the working directory and they're committed to the repo, are they, or are they a submodule of Git? If
So you basically bring in your gem file, you bring the dependency in as part of the
right. So it's like it's installed from a relative path. That's another way to get around it then, because relative paths would be obviously mounted into the container. Sorry, I'm not sure I get the question. This is, sorry, I was trying to keep it very not generic. The simple idea is that before Docker came along, it was very difficult to set up lots of different projects because obviously I think the database one is a great one. I've had a laptop in the past which had Cassandra, MySQL, Postgres, Mongo, everything installed on it under the sun. And there would always be a project that's required an additional technology or a different service like RabbitMQ, which is also a nightmare to set up on OS X. And Docker Compose helps alleviate those problems. It's not a silver bullet to development, but it does help alleviate a lot of the problems that a lot of developers come across. And I think that if you have an open source repository and you're trying to make it work, I think Docker Compose is a really important part because whilst it is a dependency to have Docker on the host machine, I think that's an acceptable one, as lots of things use Docker, and the actual market share is probably quite representative.
How do you deal with information stored in Ansible? So I believe this is referring to
how do you
deal with maybe configuration which is stored in an infrastructure management repository.
I'm not sure. I'm not sure how you would answer that.
Case by case.
Yeah, case as again.
Another one from Slack. How do you deal with multiple services requiring MySQL?
A single shared data store of MySQL.
I don't know, so maybe both answers. So maybe the shared SQL data store which you showed, but maybe also.
Well, if you define a database dependency as a service, that database dependency is namespaced within the project that you're working in. So if you have, say for example, a user service that requires a MySQL database, that MySQL database would logically be named users_MySQL. If you had two databases, it would namespace them as 1 and 2. If you had a shared data store that required two services to interact with it, you would define that as a external link so from project A to project B.
And the last question, could you just reiterate why you don't advise using something like Brew?
Well, the reason why I don't like using Brew is because it's OS X, and it's also an assumption that the developer is using OS X. Like, for example, Hamza doesn't use OS X, he uses Linux. So if you start writing READMEs and requiring Brew to be installed, where you can just do Brew install Postgres, for example, that is an assumption that the developer is on OS X, they have Homebrew installed, and that they're not on Linux, and they also, if they are on Linux, they know how to install Postgres without following Brew install.
So you're talking about being as close to production as possible. So the way we handle, or one way of handling production-like environments is to actually something like Ansible to define dependencies. So this service requires these dependencies. So what I'm concerned about is you end up spending a lot of time building Docker Compose files, and you're then going to have to re-implement that over when you start moving to production Ansible.
Yeah.
So is it not best just to choose one stick?
Yeah, I suppose the way that Docker Compose handles inter-service dependencies is to simply link them together. But I think the way they've done that is to obviously feed into their own roadmap of using Docker Swarm as part of their orchestration. So if you were to take that project outside of that, yes, you're very right. You would have to redefine those dependencies somewhere else. But as I said, Ansible or a configuration tool would contain all of the dependencies. Whereas if you have 26 different projects and project A only required project B, in the Docker Compose, you'd only need to define that relationship there instead of them all in a shared location. Sorry, I hope that answers. Yeah. External references. You mean the linking of projects in the Docker Compose? Yeah, so the Docker Compose can basically, you can link directly to another Docker Compose, but I think that's being deprecated. But if you have a project that has a Docker Compose file in and you boot that project up, it will obviously be namespaced, so you can reference it in a different Docker Compose file. Is that it? Thank you very much.